Hello and welcome to this demo where we are going to analyze the natural language understanding score and to write some code doing the natural language understanding using the evaluation described by this paper that is called SIGDIAL 22. This paper proposed to use a corpora with three corpus, okay, and these three corpus are from Stack Exchange, from Ask Ubuntu, and from a chatbot about transportation in Munich. So this paper proposed to use these three corpus to evaluate in English the NLU. Okay. So basically, it evaluates Watson, Lewis, Botfuel, Recast.ai, Rasa, and Dialogflow, and gives an overall score based on the score in these three corpus. Okay, so it seems that the best one is Watson with near 0.92 of score. So if you clone this repo, okay, that is here, you will have the code to be able to do the NLU score over these three corpus. Okay, we are using one library for the neural network that is called Brain.js, and we start by tokenizing. What is tokenizing? Tokenizing is okay, if we choose one text, for example this one, the tokenizing is basically to split into words. So given this text, we will have an array of what software can I. So basically it creates an array with these words, and we are training based on the array of these words. Okay, and for each text there is an intent, and we are training these arrays of words, this vector of words, into the corresponding intent. So basically by simply training tokenizing, if we execute, we get this score that puts our method here, but is still too low. Okay, but during this demo, I propose to use some improvements on the neural network based on modifying the activation function. By default is sigmoid, and I propose to use the leaky relo that puts us here, and also to remove the hidden layers that puts us here, and also to remove the errors, to put the error threshold, a lower error threshold, so it's training better. So we will try with this new config with changes on the neural network, and if we execute now, we see that we are in 0.88. So basically only but optimizing the neural network hyperparameters and activation function, we are here. We are in the same situation as Rasa. Another improvement that I propose in this demo is to lowercase. What is to lowercase? Okay, you see that here we have what, for example, but this feature is case sensitive, so this is different than this. So to solve that, we can lowercase the sentence before entering the tokenizing. Okay, and to do that, we get to the pipeline and we add the lower action. To see the actions, if you go to the text processor, you will see that tokenize, the only thing that it does is to split using a word splitting regular expression, and the lower, the only thing that this does is to execute the to lower case. So only but by doing the lower case, if we execute now, we are getting 0.90. If we go here, 0.90, we see that we surpassed recast.i and we are almost near bot fuel. Next thing is to use an steamer. What is an steamer? Well, imagine the words developer, developing, development. Okay, these two words are different, so even tokenized we will have, on the lower we will have this one. The steamer is to extract the steam of the word, so the steam of those three words is exactly the same. It's develop. Okay, to do the steam, there are three algorithms. That the first one is the Porter steamer, the Snowball steamer, and the Lancaster steamer. The Snowball steamer is the one implemented on our library NLP.js. That is this one. We are using the Porter steamer 2, that is the Snowball, because the performance is better than the provided by Porter and Lancaster. The Porter is not so good as Porter 2, and the Lancaster is too aggressive. But using the library Natural, that is a pretty a well-known library. If we go to github.com, Natural is this library. Okay, this library contains the Lancaster and Porter steamers. So let's try with the first one, with the Porter one. So we add the steam. And now this is use Porter true, use Lancaster false. So if we use the Porter and not the Lancaster, we will see that we improve it. Okay, and we are exactly in the same situation at Watson, IBM Watson. If we change and instead of Porter we use Lancaster steamer, we'll see that we get exactly the same result. But what happens if we combine both steamers? I mean, one word can be steamed by Porter in one way and by Lancaster in another way. So what happens if both have the same steam? Okay, we only add the word one time. But if the Lancaster steamer and the Porter steamer gives different steams, we add both to the vector of features. Okay, so right now, if I execute, I get a better result than IBM Watson by a very simple code. A simple code that you have in the text processor is very small, and almost all the score is here, but almost all is to read from the corpus and to execute, and you also has the neural network here, that is the NLU. So it's a very simple source code, and we are getting a better result than IBM Watson. If we go further, using the library NLP.js, we get almost the 0.94 of a score, because we are using a better steamer, and because instead of using the default Brain.js, we are implementing a binary relevance using Brain.js. So we are creating a different neural network for each intent. So we execute. It will take more time, because in this case there's a complete NLP that extracts also the entities. So it takes more time because it's executing the more things like extracting the entities. So we get here the score of exactly the same corpus, and we see that is 0.93. Thank you.